We have three panelists, Dominique, Francois-Bongarcon, Oscar Dominguez, and Richard Minnitt. And what I'll do to start is if we can have each panelist do a brief introduction and also say a little bit about what they think the biggest challenges that there are today related to metals accounting. So Richard, can we start with you?
Thank you very much. I don't know if I need to turn my camera on. If you'd like that, I can do that.
Sure.
Okay, let's do it. And yeah, so okay, so maybe what is metal accounting really in a sense? I think everybody understands it to be the estimation of metal in the mine and the subsequent process streams over a defined time period, or the total ore processed and total valuable metal produced, lost to waste, and held up inventory over a given time. So what are we trying to do with metal accounting? You're monitoring process efficiencies and yields, and as well as to measure the amount of material that's undergoing some sort of transformation in process units and inventories. And hopefully you're going to predict metal availabilities in parts of the process while highlighting areas where unexpected losses may occur. The problem is perhaps the prevailing expert approach is that the aim is to minimize the metal accounting variance by sampling and weighting key streams with as high a precision as possible. And terminal streams, namely the feed and product streams, are generally key to the metal accounting process. And the feed and product streams are usually measured with high precision compared to the internal stream. So it's the feed and the product that are measured, but the internal streams tend to be neglected to some extent. So the measurement on the terminal streams is consistent with the check-in, check-out method of accounting. And generally, there's what's interesting is that there's generally low usage on tailings data in metal accounting, despite the universal employment of this check-in, check-out system. So at the end of the day, it's the actual recovery that tends to override even the feed and product stream data with an extremely low regard for what's happening in the tailings. So the check-in, check-out system does not use any internal measurements to define the primary metal accounting balances. And the internal measurements within the process streams is actually perhaps the place where a lot more focus could be placed. And so, yeah, so the internal, I think, is important. So the biggest challenges maybe for metal accounting, we devote a lot of attention to it, and credibility and transparency of the metal accounting process, I think, is one of the principles that's outlined in the AMIRA code. But the problem is that while the AMIRA code does provide guidelines and principles, there's no international standard for metal accounting. There are a number of ISO standards for sampling, but international standard for metal accounting just does not exist at the moment. And as a result, companies tend to develop their internal metal accounting systems, and each metal accounting system tends to be very site-specific. So it's very difficult to find some sort of development of best practice and external audits for the metal accounting process. The other thing is that metal accounting analysts generally consider the measurements as in probabilistic terms, but financial auditors tend to work in a framework of absolute numerical precision. So they're kind of suspicious of reconciled data and preferred measured data and a clear definition of this metal accounting process. So we need to develop really a set of methodologies and best practice agreement from technical and financial personnel across the mining industry worldwide. So improving corporate governance is really important just to ensure that we do have that credibility and transparency. Better precision is obviously what we're aiming for, and to allay the fears of the financial auditors, particularly in regard to reconciled data in preference to measured data. So those were the kind of issues that I would highlight as real problem areas for us at the moment. Yeah, thank you.
Thanks very much, Richard. And I imagine that several of the points that you made will have some questions that we'll want to follow up on later. Oscar, first of all, I should say who everyone is with. Richard is visiting Emeritus School of Mining Engineering from Witwatersrand in South Africa. Oscar is a global principal geoscientist of QA/QC from BHP Technical Center of Excellence. So I'll let you take your perspective on that next, Oscar.
Hello, everybody. Good morning, good afternoon, good night. For me, the main challenge is that there is a kind of false sense of confidence that a number normally create in the mining business. We have a lot of energy and we have a lot of emphasis and try to get a number. With several numbers, you can create a database, and then we have a lot of people thinking in data processing. Here we start talking about simulation, conditional simulation, machine learning. So there is a lot of emphasis in get a number to start doing some data processing. So in my perspective, what I'm trying to highlight is how do we know if that number is really representative of what we want to represent. And that's the key. Normally, we don't have implemented proper QA/QC process to verify that. And in my perspective, there are three lines where this is important. If we talk about in a sampling perspective, in several places, even we don't know if we have an optimal sampling protocol. The other thing is normally we use process data to calibrate new technology. But if we don't know the quality of the samples we are using, potentially we can be teaching the new technology in the wrong way. And even by doing that, and using the current samples to calibrate technology, and if there are discrepancies, we will not be able to pick up. So we do have a very good opportunity to calibrate well the technology to be used potentially as a QA/QC tool as well. And finally, because there are a lot of opportunities in the way we collect the samples, there are currently new market requirements for minor elements. That the question is the business prepared to give answers to those new requirements, normally in PPM trace element. That's the main challenge I can see for me is a lot of focus on data processing, but just a few focus and understand how representative are the numbers we are using in the process.
Thanks very much, Oscar. Dominique, would you like to chime in and maybe say a couple words about yourself as well?
Sure. I'm sitting in beautiful Vancouver right now, where my company is. I've been doing research, theoretical research, applications, consulting, and teaching in sampling theory. I would like to be a little more global than my colleagues who have said a very interesting thing in 5 points. So first point, I think it's important because based on my experience, there is a lot of confusion about sampling and measurement. Sampling is not taking some material. We need to get away from that idea that sampling just consists of taking some material to measure the grade. Unfortunately, there are still some manufacturers of sampling equipment for plants in particular who confuse the two. The second thing that I would like to insist on is there are two kinds of sampling in a plant. You have a lot of sampling for process control, where you monitor trends in reagents and products. And to monitor trends, you don't need samplers that are unbiased and very precise. So you just need to be able to see changes. Those samplers are usually not adequate for quantitative metal balance. Metal balance requires both unbiasedness and precision. And normally you should not use the same samplers for process control and metal balance. Unfortunately, in many industry, like especially copper and gold, people realize that, and usually after the plants are built, they go on the market and they buy special sampler for metal balance. In the lead zinc industry, the base metal concentrate, people, except for copper, people have a tendency to use process control samplers, which I think is a big mistake. Indeed, my third point is, in a metal balance, you need to take into account errors on the measurement and possibly biases. Now, errors, all the measurements you put in the balance are affected by errors, so sampling errors, analytical errors. You cannot assume that one stream is perfectly known and another one is subject to error. All the streams are subjected to errors, and it is very important to take those errors into account in the balance. And basically, that means that the usual spreadsheet in Excel, where you fix the head, you recalculate the head grade and you decide that the tails content are perfectly known, is not cutting the work for you. There are a number of good software I've developed that do dynamic balancing, whereas you put error margin on every measurement point, including the entry to the plant, and then those software, I will not give any names, but you can research them, they will realize the balance that minimize the adjustment globally at all the points. And I think good metal balancing should use some of those software. Then I speak about bias rapidly. Biases are a very bad thing. It's about the worst thing that can happen to you in sampling and measurement, because you are very ill-equipped to counteract biases. If you have systematic bias, you might be able to quantify them and then eventually correct for bias. If your biases are transient, you must make sure they turn into noise. And there are ways to do that. Bias are very important, and that means that no biased sampler should be used. And that's one of the reasons you should not use any of the process control sampler for metal balance. My fifth point is that you also have to think about what's the objective of metal balancing. The objective of, let's see what it is not. The objective of metal balancing is not reconciling well with sales and mining. These reconciliation are tools to try to understand what's going wrong. They are not an objective per se. There is a big difference here, because in essence, a lot of people consider that the plant is always right and the geologists are always wrong. The world is not like that. There is no reason to consider the result of the metal balance as more reliable than the best estimate the geologists and the miners are doing on what enters the plant. They are both of equal quality usually, and you need to take that into account when the reconciliation is bad. What it is not also is the objective of the metal balance is not to get good figures at the end of a monthly report. The objective of the metal balance is not to try to demonstrate that you have good metal recovery and try to make that number as high as possible by taking it a little bit easy with which measurements you use and which measurements you don't use. The final word is that metal balance should give you the best possible picture of the truth of what's going on and the reason why you want to do that. And the mine and the geology should do its own work on their own stuff in a similar manner, is because if you know what is actually happening, you might be able to further optimize your operation and your process. So that'd be my concluding remark.
Thanks very much, Dominique. So for a follow-up question, and please, anyone, if you have some questions, feel free to put them in the chat window, and we'll go to them as much as we can. But each person talked a lot about the challenges that they see and where, as an industry, we need to go. My question is with where metal accounting is today, if you were doing system design, what are the things that are most important to you, and what are the things that are least important to you? And maybe I can go to Oscar first for that question.
I think well, I can be a little bit biased because I keep a focus in the QQC. So as I was saying a few minutes ago, for me, before I start talking about systems, and normally we do have in BSP meetings in regards to systems and new equipment, and start thinking about the control points or in feeder and concentrate or final product, etc., etc. For me, as I mentioned, it's about to have quantified the quality of the information we are putting into that system. Something that hasn't been mentioned yet is that normally, or unfortunately today, QAQC or quality is considered as a cost. Yeah. So in the way that we are promoting QAQC is a very pragmatic approach. Is for me the first step now is try to understand and quantify the current state of our control points, and then as Dominique and Richard were saying, try to incorporate that in the global equation. That's the first thing that captured my attention today, is how do we know the sampling port are doing what is expected, try to quantify the variability, and also try to quantify if, finger crossed, we are not having a bias in the process. Normally, those parameters are just assumed as correct. So again, that's the first step for me.
Thanks, Oscar. Dominique, can you elaborate?
Yes, here I am. Yes, I think Oscar is absolutely right. The best way of using our tools as a, from sampling theory is make sure biases are not creeping in. Biases in measurement can go for years and years without being detected. And so that's two consequences. The first thing is you should really work hard to see as much as you can if you have any bias in the system. And the second thing is you should absolutely not use any type of sampling equipment or measurement equipment that may generate biases. And sometimes, if you really want to do that, it's always possible. Sometimes the cost is high because the plants are not always built properly to be sampled, but sometimes it implies sampling somewhere else where you can actually install a system that give you some guarantee of non-bias. Sampling theory has formalized that. We know how to guarantee the non-bias. You should do it, even if it costs money. I think that would be the main thing I would see, especially in the installation of a system. I want to mention that sometimes things are mind-boggling. I have worked for a client along with another colleague from the sampling theory expert. And what we discovered is that that particular operation was putting more than $100 million of metal in the tailings that were not detected by the sampling. So they did not know it. We found out why. We found out what in the sampling, and by the way, they were using process control samplers. The problem was that figure. That was really the lower end of our estimates of how much money they were losing. That figure is so is so incredible that they dismissed both of our reports. They turn into denial, And today they're still putting, I believe, $400 million. Let's say maybe our calculation fooled us a little bit, but certainly it's more than $100 million worth of metal in the tailings that they could actually put in the production. And that's a nice budget if you want to revamp a plant and change some of the equipment, process equipment and samplers and so on. But in that particular case, we were faced with denial. Okay.
No, thanks very much. Richard, I think when in your initial point, you added a few different suggestions about the difference between the importance of product and feed versus some internal streams. I wonder if that ties into how you would design a system from the ground up, or whether you have some additional thoughts.
Okay, one of the things that really sort of, there are 2 points that I'd like to make. There's a lot of work that has been done, particularly in the South African gold mining industry, where people have created extensive processes to get ore flow balance sheets correct. And this is going, one of the things with just talking about metal accounting is that we tend to immediately think that it's only what's happening in the plant. And it's not. It's a far bigger problem. It's a problem that arises in the open pit or underground where drilling has been done. And these data are passed on to the geostatisticians or the resource estimators or reserve estimators. They create a document that states how much is going to be extracted or should be extracted. And then between that point where the rock is actually broken and it ends up in the mill is a huge area of contention. And just the way that that is sampled. And as a result of that, at the end of the day, generally what happens is that the people from the mill are in constant Cold War state with the people in the pit or the geologists or the evaluators. And mine managers can easily be accused of throwing gold away. But really, it's a much bigger problem than just what happens in the mill. Okay, so that was my first point. I think we need to get to a stage where we have a industry best practice for what should be happening from the rock face to the mill. And then from the mill, we need to have a sort of an integrated an appreciation of the fact that these should not be siloed, but rather that they integrated processes, and that what's happening in the mill is in fact part of that process, part of the whole metal accounting, metal balancing, ore flow balancing sheet, and that what's going out to the tailings in particular is a really crucial issue. Now, I know that others have mentioned the tailing issue quite considerably, but it's interesting. If you go to any mining operation, one's got to be careful what I say here, but maybe not any mining operation, but a lot of mining operations, and there are two things that mines don't like you to do. They don't like you to go and sample on the waste dump, and they don't like you interfering with the flow of material that goes to the tailings dam. That material is considered like almost an out of bounds. And what my concern is that companies like Ergo and DRD and other mining companies are making huge profits out of waste dumps that ostensibly contain nothing. So I feel that we really, really need to focus very seriously on what's happening in the tailings. Nobody has done, as far as I know, and I've looked around quite carefully, nobody has done any major sampling studies on tailings. because they're supposed to have nothing in them. And yet other people are making a lot of money out of these tailings 40 years later, 40, 50, and 60 years later. So it's a real, to me, the tailings, and often people will measure what's in the tailings, and then they'll do a back calculation to try and explain what the head grade of the mill feed was. I mean, to me, it's just like we're chasing our tails because we don't really have a good grasp on what's happening in the tails at all. I think what we should be doing is taking like 55-gram samples and doing heavy mineral concentrate and actually seeing what's happening in those tailings, because I think a lot of larger gold grains, they don't have sufficient residence time in the cyanide tanks. It's just going straight out to the tailings dam. If by any chance the people in the assay lab get a sample with a very high gold grade, they immediately discount it and take another sample. You know, that sample was incorrect, but it's not. It's telling us truth, and I think we need to just follow that. Yeah.
I found that very interesting in that there's a few points from the three of you about bias, about input data, and then about the systemic challenges of really being able to balance the data from other parts of the operation within the actual metallurgical facility. There's a question from Patrick, and he's got a two-part question, and it touches a little bit upon the mine-to-mill reconciliation, but he says, every site is unique in its own way in terms of processing streams needed for metal accounting. What would be the acceptable bias in measuring systems? I understand this is subjective, but from your experience, is there a number or range that would be acceptable? And will a mine-to-mill reconciliation aid the metal accounting system? So why don't we go to Oscar? I'm curious for your perspective.
I think normally we have the trend, or we try to standardize or processes or commodities in a very global level. I think he is mentioning that every mine is unique. So more than to say a range where that reconciliation threshold shall be, we've been trying to do the calculations independently for every specific asset. Even in a geological perspective, every single deposit is different. So more than to try to standardize some thresholds, I think we should start questioning, okay, how much the business is able to accept as a risk. I think that this is something that hasn't been mentioned yet. So the reasons why I've been pushing to quantify quality is because if we have a quantified quality, we can assess the risk the business is running, and based on that risk, the business, individual companies will be able to say if that level of risk is good or not, and then if the answer is no, they will be able to take decisions and purchase and improve or take actions. So going back to the question, I think that today we tend to try to standardize and try to put some big threshold. For me, it's about to quantify individual asset first.
Sorry, I lost the screen. So, Dominique, I see you've got your hand up.
Yeah, I agree with Dick and Oscar, but I would like to put in context the problem of tailings that Dick was speaking about. And then I would like to make just a quick remark on reconciliation. The anecdote is this: it's a client of mine the other side of the world. I will not mention which kind of operation, but it's a base metal operation. And during the first phase of that operation, that was reported to me, the geos and the plant kept fighting over the tailing grade. And the plant say no, the measurement, the sampling is good, and the grade of the tailings is about 0.2% metal. Okay, and during years and years, I thought about that figure because the geologists felt that the plant was putting more in the tailings. But anyway, that's it's a classical. Okay, what happened is they mined it out, and then 1 year later, they found that they would be able to retrieve the tailings. So they built a plant to retrieve the tailings, and the same process department was transferred to that new plant. And then they started operating it with a head grade of 0.45% metal. The same process people who had been so adamant the tailings were 0.2% metal, now they're operating it with the tailings at the head grade of 0.45. So that tells you how much one can be wrong on believing a grade that has been measured in the tailings. Of all the streams, the tailings is the most difficult to measure. There are some problems that I think are still unresolved. One of the very interesting problems for those involved in gold is that if you have a process that pulsates erratically or not continuously, but pulsate coarse gold in the tailing streams, it is very difficult to catch that and have a proper estimation of the tailing grade. And this is a problem that has not been resolved to date. Periodic sampling seems to be missing pulses of coarse gold very easily. The global remark I wanted to do, just to put the discussion into context, since both Oscar and Dick spoke about reconciliation, is this. The metal balance is just one of several tools, and I insist, tools, in the frame of global reconciliation of the operation. Itself, that reconciliation, that global reconciliation between mine, plant, and sales, that global reconciliation is just a tool in the frame of optimizing the various components of the operation. So you see, metal balance is a tool, not an objective. Reconciliation is a tool, not an objective. And I really think that if people were thinking in those terms, a lot of the conflict would disappear. I remember a conference where somebody, a consultant, was showing a fantastic reconciliation study where everything matched very well. At that time, we had a very good friend in the industry called Pedro Carrasco. He was a head of resources and sampling for Codelco Chile. He cut that presentation short. It was in Perth. It cut it short in the middle of the exposition, which nobody does normally in a conference. And he said, it is when I see figures like these ones, those very good reconciliation, that I start being really worried. People should realize that reconciliation, not only is there not an objective, but it is very suspicious if you have good reconciliation. You should not have too good reconciliation. If you have very good reconciliation, that means a lot of factors are being applied here and there to force the reconciliation to be good. Reconciliation cannot be very good. They should not be very bad. They cannot be very good. But what is important is how the difference changes as a function of decisions you make on your methodology on either side of the reconciliation. So basically, if you think in those terms, metal balance is just one tool in the reconciliation story, and reconciliations themselves are only one tool in what? The look for optimization, the search for best optimization of all the components of the operation. And what is absolutely tragical in many operations where geos and mets are fighting over reconciliation is that everybody spends a lot of energy and time trying to demonstrate the other guys are wrong. And during all that time, no effort is spent on trying to see what can I optimize on my side of the equation. And nobody is optimizing anything. And when you don't optimize, you lose money. By definition, the optimum is when you lose as little money as possible. That's
Thanks,
what
Dominique.
I wanted to show.
Dominique, and you have a question that I think was follow-up from something. Hello?
Marcus, may I make
a sure.
small
Yeah,
comment?
Oscar, go ahead. Yep, please.
No, following what Dominique is saying, I think that in a pragmatic approach, sometimes I think we do have the opportunity to see the whole reconciliation process in a more holistic perspective. It is not about geologists against processing plant or vice versa. I think we can discuss, but in some places, we do have reconciliation, and we have geoscience showing the QQC implemented in their data. We need to consider the compliance to plan. We need to consider the QQC process. We have a processing plan, etc., until port. So I think that is potentially a good practice. Sometimes reconciliation is some decisions that you can take in a 2 by 2 meters room. So in some places we already start having the whole day where everybody's presenting and it's not one against other. So we need to elevate a little bit higher the discussion and to have a more holistic approach. And even by saying that, in some places, even we've been thinking to have an independent dealing with the quality, or dealing with the quantification and the quality, and from geoscience to processing and port. So in having the governance, an independent team having the governance and having the same tools, even a few basic things to have the same reference material to measure the laboratories in geoscience and port and processing plants, even so those small details. But the thing that I would like to discuss is potentially elevate a little bit the reconciliation process, and more than to fight each other, is to have a more holistic approach.
Thanks, Oscar. Richard, you didn't get to answer this question yet. Do you want to mention something, or do you want to go to the next question? You're on mute right now.
Marcus, if you don't mind, can you put the question on the screen?
Yeah, sure.
When you read them?
Yes, I can do that. So let me just go find it. Okay, so the question that we were bringing up was really about where was it? It's up here. So every site is unique in terms of process. What's the acceptable bias? Is their range just acceptable? And also he asked about mine-to-mill reconciliation, which I think were a lot of the view about like holistically thinking about the systems. I think we've been addressing that question. So Richard, do you want to take a shot at it, or do you want to move to some other questions?
Yeah, look, I mean, the measurement of bias and the understanding of what's happening in each individual plant is going to be very site specific. And I think it's difficult to, I mean, there are standards for the way that bias can be identified, and a bias that's acceptable and bias that's unacceptable. And so I think it's the responsibility of those at the plant and at the site itself to determine exactly what those are and how they're going to overcome those things. So I don't know that there's any specific hurdle or threshold that we need to say that if your bias is above a certain level, then that is absolutely unacceptable. It depends on the operation itself, and it depends on the type of mineral or metal that is being processed, and it needs to be looked at in that way. My feeling is one of my main concerns is, and I'm just looking at this question by Karen McCaffery, in regard to guidelines for the code of practice that could be improved on in terms of the AMIRA P754 project. I'm not. My only concern there is that the AMIRA code is a wonderful code. The people did a fantastic piece of work there. The only thing is that it relates only to what's happening in the process plant, and we've got to extend the reach of where our metal accounting is actually going to. It's got to go back further than just the head grade to the plant. and it needs to look in detail at what's happening at the tailing stream. Also the product stream. The other thing that I just feel that's quite important, and Oscar, you mentioned that it's not really a tussle of wills between the people in the mine and the people in the process plant, but really the financial managers and the people that are sorting out the finances, they want to make sure that what's happening in the plant is absolutely 100% squeaky clean. So they don't want any, they want as little problem there as possible. And as I say, I think it's a much bigger problem than just trying to focus on what is happening in the plant itself. Yeah.
Dominique, I see you got your hand up. Go ahead.
Yes, on that question, I would like to mention a very clever, brilliant piece of work that one of my clients did in a very large operation in Brazil, where basically what he did was he simulated the entire balancing process, and including the geo part. And then he was able to do a sensitivity analysis to see, well, if I have a bias on that particular point, what's the overall impact on the operation? It's a very good way to analyze how big a bias is acceptable to the operation. And sometimes the results were very surprising. So I think he used some Monte Carlo simulation at one point in time. It was very, very interesting to see what's going to happen if the tail is biased a little bit, if the head is biased a little bit to the reconciliation process. Very good tool, but it's very complex because you have to analyze the entire balance, including input to the plant and the output, and then simulate it very carefully, and eventually have an idea of the margin of errors within which things can change. But it's a fantastic tool to see what the effect of a given bias is.
Thanks very much. Let's go through a couple other questions. Let's do one more, and then we'll have everyone provide some final thoughts. So this might be a specific one for Dominique, but what's your take on the tailing sample being transferred through a sieve prior to sample prep, that is screening out possible carbon particles?
Yeah, well, I'm not a metallurgist, so I would not know for sure. But what I want to add to what I just said is that the reason why that work was done, that sensitivity analysis on possible biases, is my client was facing a major reconciliation problem between the mine and the plant. And we had no idea why it was. And we spent months on that reconciliation. And, you know, at the end, what it was an enormous bias in one of the devices that were used for sample preparation. So they changed that piece of equipment, which was apparently a very good piece of equipment. It was a pulp divider. At one point in time, they had a large pulp. I don't remember if it was, I think it was the tailings, yes. It's one of the tailings. They had a large pulp, like, you know, 40 liters that needed to be divided in a small quantities that you can prepare an assay. And so it was a classical rotary pulp divider. You know, you would liberate the pulp into rotating carousels, basically. And what actually happened is, against any expectation, we pinpoint this as the origin of the bias. And then once we knew it was there, then we could eventually elaborate reasons why. And the reason why is it was on gold, and the gold would concentrate at the bottom of the trough that was used before dividing it. The agitation created a vortex that actually concentrated the coarse particles at the bottom of the container. And when they released the material over the carousel, most of the gold would fall on the first container. And then they would take one at random. So most of the containers did not contain that enormous spike of gold. And if they did contain it, probably it was so big that they would discard that data and and do the balance otherwise. But the idea of screening the carbon, I think I am not competent to answer that question really directly.
Thanks, Dominique. We're now with a few minutes left, and actually Karen McCaffrey had added a follow-up question that will lead into the final answers, I think. But throughout the session, we've talked about a few things fairly repetitively, whether it's the need to have more of a holistic view throughout the metal accounting process, where you're looking before the plant and then into the tailings. We've talked about how to have proper governance across multiple different sites, especially with the knowledge that each site is individual, and being able to have that governance in light of that. And then this question from Karen is, so we're looking at a guideline that covers metal accounting through the whole value chain, from resource to reserve, through waste streams to metal sales, and all steps in between. So that would be the final question to elaborate on. Based on everything that was said today, what should we do about it? And Richard, you got your hand up, so you get to go first.
Okay, can I just make a comment here? One of the biggest problems that I've seen in a lot of gold plants in South Africa is that the head grade, or the feed to the mill, is sampled on what we call a go belt, or in some other method just before it gets to the mill. But and very often that is considered to be the feed head grade. The problem there is that it's usually a cross belt sampler that takes that sample. The top size of material that is on the belt is a maximum of 30 centimeters, but it can be a bit less. So it's the fragment size is enormous. The sampler is not it's not the best of samples. It would be far better to take a cross-stream sample if possible. And really all that's needed is that instead of feeding the material from underground or from the plant straight onto the conveyor belt, is that it should go through a primary crusher first to reduce it to less than 2 centimeters. If they could do that just as a simple step, and all it means is just installing a primary crusher at the right place, it would solve a huge number of problems. So, yeah.
Thank you, Richard. Oscar, do you have some final thoughts?
Yeah, in regards to the question, I think we can tackle in two different ways. Yeah, we can develop something that is specific for processing plant and try to describe good practices for processing plant. But I would like to say that we need to keep a holistic perspective as well, because at the end of the day, we can have an excellent process in processing plant, but a bad geology or bad practices at core. That's why that we need to keep an eye in a holistic perspective. So potentially we can have in the value chain areas doing it perfect, but then the value we've been trying to add can be destroyed if we don't see it in a holistic perspective.
Thanks, Oscar. Dominique? Yes, I'd like to make just one big recommendation here, and I know it's an upward struggle. It's very interesting what Dick mentioned, because in South Africa, virtually all the mines of South Africa, the head is sampled. They have the huge go belt samplers. We could speak about them because they have a tendency to be biased, but it doesn't matter. The heads are sampled. In the rest of the world, not only the heads are rarely sampled, but all kind of argument is used to fight the willingness to install any kind of sampling system on the head. All kind of pretexts are found, whether they're financial or maintenance, to not sample the head. Because once you sample the head, of course, suddenly some people are restricted in what they want to take things easy with, you know. But as a professional of reconciliation between mine and plant, I can tell you, you should always install a sampler on the head. And it does not matter if that sampler is not very good. It doesn't matter if it is biased. Because the first step, when you try to reconcile, to study the reconciliation between the mine and the plant, is to see
how each one reconciles to that head sampler. The reason why it can be biased and you can still do the analysis is what it is telling you by looking at the difference along time and what happened when certain things change and so on. You get an idea what's going on. You get an idea very quickly whether there's a bias in reconciliation, if there is a bias, if it's more on the reserve side or if it's more on the metal accounting side, just by looking the comparison to that sampler. The second thing is, if you do install a sampler that everybody trusts, if the sampler is very good, and it can be very good. You know, it is not true that you cannot sample a belt because the blocks are too big. You can sample anything in life. Sometimes the cost is too high, but we don't know anything that you cannot sample quantitatively. Okay, and even large block on a belt, we know how to sample this. It can be measured. The cost can be atrocious, but we know we can sample it. But if you do install a very good sampler that is reliable, and if that sampler is trusted by everybody on both sides of the sampler, I mean the process department and the geology and reserve department, if they all trust the sampler, then suddenly reconciliation problem becomes a lot easier, because the sampler is the arbitration between two components. You can reconcile the geos with the sampler, you can reconcile the process with the sampler, and you do not have to reconcile two parties that are fighting each other. So my big recommendation would be try to sample the head. If it's a very, very difficult head to sample, it will still be very useful. If it is a reliable sampler, then suddenly you have a benchmark against which the mine and the plant can measure themselves. And usually you will see as a result a lot of optimization on both sides and a much better operation.
Well, thank you very much, Dominique, and thank you to Oscar, and thanks to Richard as well. We really appreciate that you've all been able to take some time to participate in the session. And